Efficient irrigation is one of the key earth-kind practices for conserving water in the landscape. Low-volume irrigation systems, sometimes referred to as drip or trickle irrigation, are among the most effective means of achieving significant water savings. Despite the tremendous potential for water conservation, these systems are not widely used in residential landscapes. Like conventional overhead irrigation systems, low-volume systems require proper design, installation, maintenance, and operation for optimum water savings and plant performance. Unlike overhead irrigation systems, the primary design goal of a low-volume system is to apply water to a uniform soil depth, either directly to the plant root zone or in a limited area. Water is delivered at or below the surface of the planted area versus to the surface of the planted area. Most low-volume irrigation systems are installed at or near the surface of the landscape area and covered with 2 to 3 inches of mulch. Typically, this type of installation requires less time and cost than a conventional overhead system. In some commercial applications, the system is installed in an underground trench and exposure of any drip tubing is minimal. These types of sub-irrigation systems are becoming increasingly popular for turf grass applications. Maintaining a low-volume system requires careful attention because problems may be less noticeable than a conventional overhead irrigation system. A clogged emitter, leak, or other breakdown in the system can be difficult to detect since components are often not visible. However, most problems can be repaired faster and more easily than conventional systems. Like all types of irrigation systems, if not operated properly, low-volume systems can be wasteful and ineffective. A thorough understanding of the landscape's soil, plant, water relationship is critically important in determining how much water should be applied at each irrigation. Low-volume systems must operate within hydraulic specifications and operating pressures for optimum performance. It's important to remember, irrigation systems don't waste or save water, people do. One of the most important benefits of a low-volume system is the potential to reduce or eliminate water waste. Low-volume systems do an excellent job of applying water to meet specific plant needs. The rate of application also more closely matches the soil's infiltration rate, and water is directly applied to the plant root system to maximize water use efficiency and reduce loss through evaporation. Since water is directed exactly where it's needed most, very little is wasted on areas between widely spaced plants or on streets, walks, and gutters. A conventional sprinkler system can spray water onto windows, erode paving, wash away paint and plaster, and rot wood. A low-volume irrigation system keeps water off window streets, walls, and fences, which helps reduce the maintenance costs associated with replastering, repaving, repainting, and rebuilding. Numerous studies have shown that low-volume irrigation is more effective at maintaining optimum plant health than conventional overhead systems. The top half of the plant's root system absorbs approximately 70% of the plant's water and nutrient intake. Because low-volume systems apply water at or below the soil surface, these systems do an excellent job of meeting plant water needs, reducing stress, and enhancing plant health. Low-volume systems also assist in reducing significant fluctuations in soil wetting and drying. When properly managed, low-volume systems optimize soil moisture levels between irrigations. This also enables landscape plants to tolerate higher levels of salinity in the irrigation water. Since low-volume irrigation limits the amount of water on the plant's foliage, these systems can greatly assist in avoiding plant diseases. There are numerous types and configurations of low-volume irrigation systems. Here are just a few of the most common examples. A soaker hose is one of the most basic means of applying supplemental irrigation to the landscape. Small holes in the hose provide a low volume of water which soaks into the soil. A soaker hose can be moved to various locations within the landscape, or it can be left in a more permanent location and pressurized by a regular garden hose as needed. A porous hose is very similar to a soaker hose. However, its unique construction enables the entire hose to deliver irrigation water. These systems are frequently used in landscape beds and are also used in sub-irrigation systems for turf grass. A porous hose can be an effective means of providing water to the landscape. However, the delivery rate can be somewhat variable in areas that are not level. Drip systems typically use polyethylene pipe to deliver water to a small drip emitter. Emitters come in a variety of sizes, shapes, and specifications. Most are rated in gallons per hour, making it relatively easy to determine how much water is being applied at each irrigation. Drip emitters can be spaced evenly along the delivery pipe or clustered at specific locations within the landscape area. Drip emitters with pressure compensation and backflow prevention provide optimum control over the volume of irrigation water supplied. Carbonates and bicarbonates in the water, sometimes referred to as hardness, can affect both porous hose and drip systems. Successive wetting and drying cycles can cause these salts to form deposits which limit flow rate or render the system inoperable. A pre-filter can help address this potential problem, but long-term use usually results in some system breakdowns. That's why a good maintenance program is critical for optimum performance. The use of a good low-volume irrigation system is one of the most valuable earth-kind practices available for conserving water in the landscape. These systems are typically low cost, easy to operate, and relatively maintenance-free. Despite these advantages, low-volume irrigation is not widely used in residential landscapes. Putting low-volume irrigation to work can be an important key in creating a healthy and sustainable landscape environment. For more information, we invite you to visit our website at earthkind.tamu.edu.